For the 2025 BPhO Computational Challenge, we developed a website, accessible through the URL above and in the description of this video.
For task 1, refractive index was plotted using the chart.js library. The color of the curve corresponds to the color of light at that frequency or wavelength.
Task 2 was plotted similarly, and the graph revealed a strong correlation. The focal distance of the lens was determined to be around 15 centimeters.
Task 3 was implemented through a dynamic graph with slider inputs. The minimum value of the curve was shown to correspond to half the distance regardless of input values.
Task 4 followed on from Task 3. Using the value of x at the minimum time, sin theta and sin phi could be calculated, and Snell's law is shown to be valid.
Task 5 used WebGL to render an image reflected in a plane mirror. Sliders were added to allow a more interactive experience, as well as an option to upload a custom image.
To complete Task 6, we computed the required lens transformation and made the lens adjustable. The same WebGL rendering structure is reused here and in the upcoming tasks.
Task 7 was similar to Task 6. The code from 6 was reused, with only the equations being changed to simulate lens transformations inside the focal range rather than outside.
Task 8 simulated a reflection in a concave spherical mirror. Parameters like mirror and object position can be freely changed using the sliders on the web page.
Task 9 only required altering the logic of Task 8's code to simulate a reflection in a convex mirror instead of a concave one. The structure is very similar when compared to Task 8.
Task 10 maps a customizable image from Cartesian to polar coordinates, centered around the base of the image. This produces an anamorphic image when viewed from a cylindrical mirror.
Task 11 was another plotting task, and using Descartes' model, the angles of elevation and refraction of primary and secondary rainbows were graphed for a range of inputted frequencies. All plots were color-coded by frequency, as in Task 1. Part D also showed how rainbows would be observed for any inputted solar angle alpha.
Task 12 was an interactive model showing the dispersion of white light in a triangular crown glass prism, which required calculations from Task 1. Part A is a dynamic render of the dispersion, while Part BI and II plotted transmission and deflection angles versus incident angles for the same given input frequencies and prism apex angles.
The extension task was to model a human eyeball with the light rays passing through a concave eye lens and a concave or convex glasses lens to demonstrate myopia, hyperopia, and their corrections. Changing inputs showed ray bending with and without lenses at different lens positions and focal distances.
We wrote up 2 papers to accompany our website, one covering Fermat's principle and including detailed information on how we coded up tasks 3 and 4, and the other on the rainbow-related physics and tasks, specifically about Descartes' model and his calculations.
Our website can be accessed at opticalcalculator.com, and all papers and other resources are listed in the About page.